Good morning. So this is my first time come to the XLDB conference. Although I heard about it, my co-workers, colleagues had been here before. Before Uber, actually, I was in Facebook leading the data infra group, and that seems to be a much closer field. All the sessions I heard from yesterday, today actually echoes a lot. The session TD just talked about the distributed metadata for that's kind of the problem I battled for a couple of years back in Facebook. At Uber, as I introduced, right now I'm supporting a field called financial intelligence. I've been in Uber for about 3.5 years. The first year, I lead a small team to do predictions on the fraudulent activities on Uber platform, try to predict. So we have about sub 20 milliseconds time to actually, given a transaction, given a request, to determine whether this is a potential fraud, and then whether we allow it to proceed to request a car. For the last 2.5 years, I started leading this area called financial intelligence. And so today, the topic is more covering in that field. So this is actually, I feel that this is not so much about the technology itself, but more about talking about the business problems that we try to use technologies to solve. I want to repeat the same thing that a lot of people already said. I'm not a database guy. I'm not a data scientist as well. My technical field is storage system and in general kind of a system space. And it's just happened in my last 2 jobs being involved with a lot of with data, a lot of with the using data to provide analytics. And also before I dive down, one heads up, I'm not going to strictly follow the flow of the deck. The reason is, given the stage that Uber is on right now, there's a lot of paranoia in the company about anyone give public speak. My approval for speaking in this conference literally just approved the day before. And this deck has been extensively reviewed by legal and the public communication group and has been edited, censored. So most of the interesting content has been gone. All the key metrics gone. Anything about the business operation. So the good news is I saved 3 pages of disclaimers that I don't need to go through that. So that's that. So I'm going to go with my pace and bring up the slides whenever it's relevant. This is the model that Uber's recently invented, and we ignite opportunity by setting the world in motion. So think about business decisions. One of the most fundamental business decisions almost every business needs to make is, given a fund, where should I invest next? Right? What is the most effective way to invest our budget? And so the core mission of the financial intelligence group that I'm leading at Uber is try to provide an intelligent answer to that. Essentially is looking at Uber, the way that Uber is operating in dozens of countries and hundreds of cities. Each city and each country has their unique way of responding to the actions that a company take. And our job is to understand those behaviors and try to use that to predict how Uber is going to be performing in those cities and the region, and try to deploy the limited resource, the funding, the people into those markets that can make the biggest impact to the human life, to the community. And in order to predict, we try to degenerate the question. And one of the most fundamental questions is, how many, something like this is, how many drivers do we need, let's say in December 2019 in San Francisco? That will give us insights towards what is the potential future scenarios. And so if I generalize this statement in a way that I replace city of San Francisco to city X, that statement becomes, how many drivers do we need in December 2019 in city X? Is it December 2019, or is it this hour of this day in December 2019? depends on what kind of, I will talk about that, but depends on what kind of horizon that we're looking into. Second is, if I replace December 2019 to time t, that statement becomes how many drivers do we need in time t and in city x. And then I can further generalize, say, replace drivers to an entity A. That statement becomes how many A do we need in the time t and in city x. So that's kind of for the multiple dimensions that we need to understand how to get that insights. And then with that insights, let's say, fundamentally, the Uber's business essentially is a microeconomic market. You have supply, you have a demand. And there are different ways that we influence supply demand. And those key metrics that we predict can help us to understand how the supply and demand actually is cross with each other. So how far do we plan? So that really depends. For the tactical planning, we are looking at very precise on the hours and potentially sub-hours within 4 to 6 weeks. And this is try to determine how the incentives and the promotions and what is the pricing of a trip and or any of the service that we can charge. But there's also a long-range planning that we can determine how strategically we want to deploy our funds. And that is a 12 to 18 months forecasting, that we want to understand how the business is going to be performing at a given city at a given time. And with that information, we can actually compute what is the market equivalent that can generate the business predictions. The financial intelligence group that I'm leading is primarily looking into the long-term forecasting. I sometimes equip this as a long-term weather forecasting. You can understand the trend, you can never be precise. And as we approach to the time, as more data is available, we can make it more accurate. And we can try to always refine the prediction so that we can provide insights. But having an understanding of 12 to 18 months will help the company at a high level to determine how do we balance our resource and how do we kind of generate the biggest impact. So at fundamental level, how do we predict that one, let's say given one particular metric, how do we predict? Let's say from the trip forecasting perspective, first of all, of course, we have a lot of historical data, the trips that we performing in any given city. And each city, we have a different set of historical information. We have all the spending information. So the way that we organize information is in the way that say, there are, for any given city, there are a number of actions that we can take. And the prediction target, specific prediction target, essentially is a function of the actions that Uber take in those markets. So our job for that particular prediction is to understand what that function is. And given the inputs is essentially all the spending information. For example, one of the potential target is to predict what is the new driver sign up in any given month in any given city. And potential influence the actions that Uber take for the new driver sign up is, for example, given promotions to to reference. People reference the other driver coming on board. So those kind of marketing spend will influence the outcomes. And the historical spending area and the potential result from those spending help us to actually try to predict or try to first understand how the function actually works. If fx, the x is the action to a target and how that function will look like. And then there are major events in those cities that will influence. And now, for the many of the events, if there's a kind of a long-term schedule that we know those events happen, particularly, let's say, the national holidays, and those are the predictable events that happens, and we can understand what are the impacts that those events towards the user behaviors. But there's also what we call market shocks. And market shocks are the sudden events that happened, and those are things are hard to predict, but the past trend can give us a little bit insights towards that. But also, for the market shock, we actually more looking towards at the real time to get the market inputs and try to incorporate into our forecasting. At the end of the day, it's time series model.
Is a big event something? Are you counting something that occurs as well? Like the New York Marathon, do you consider that a big event, even though it's very predictable every year and you can kind of know what's happening?
That is more of a localized event, because let's say marathon or this kind of event is localized within a district or within a region. That one does change, but the long-term model pretty much assume the data sets that we collect already incorporate the influence of the local events. The events that we really want to incorporate from the long-term model is things like national holidays, which has the impact for system-wide impact.
Got it.
Yeah.
National, like July 4th or whatever.
Yeah. So at Bayesian those are essentially time series models, and we want to predict at time t what is the outcomes. But the next level of the prediction is really about, for each of the time series prediction, there are different behaviors that the target may responding to the actions, and that's the fundamental actions that we are taking. There are different algorithms, time series forecasting algorithms that we try to incorporate for different city, different market. The effectiveness of those algorithms may be different, and largely, when I say that we want to understand what are the impact of different actions to the market, we really want to construct what is the future scenarios that we have, and we call it essentially cohorts. We try to build the cohorts, and our job is to predict a future size of the cohort. Let's say 3 months from now, what is the new driver sign up in this city? Or 6 months from now, what is the first paid trip that a city can come up with? So with those cohorts, we can actually try to stack up the behaviors, and then taking those inputs to construct the macroeconomics functions. And then, I'm not sure if it's visible. Yes. So first trips. So this is actually for anyone signing up on the platform. If they just sign an account, do nothing, it doesn't really generate any actions. So the first trip actually is very critical to predict. And then the next is the retention rate. You may have 1 million people take first trip. 3 months from now, maybe half of them still active on the system. So understand what is the retention rate for each market, and what are the trip and active users after that. And then given the, I mentioned the market spend. The market spend, essentially, there are ways for us to influence this formula. And so the fundamental prediction or understanding that the team's building is understand what is the different level of the investment that may generate the outcomes. For example, let's say just hypothetically, let's say in New York City, if we spend $1 million to attract new drivers, we probably can attract, let's say, 300 new drivers. In Bangalore, if we spend $1 million to attract new drivers, we can probably attract, let's say, 1,000 or maybe 10,000 new drivers, right? Now, but each city, the average spending is different. The average trip in New York City is about $15. The average trip in Bangalore is $3. So although we have the same investment, the outcome is different, and the potential business value that can be generated is different. So it's very critical to understand for each city. It's essentially pretty much follow a log function. For each city, given the different spending level on an action, what is the potential outcome? And then it's actually very critical to make sure that the supply and demand are balanced. So if you only increase I think that's microeconomics 101. If you only increase supply or only increase demand, that doesn't create a market effect. If you have more drivers, each driver's earning will go down, and people will drop from the system. If you have more riders, they cannot get enough drivers to satisfy the demand, people will go to the other platform. So we have to actually balance both supply and demand so that simultaneously there's a corrective function to actually bring those metrics together to understand what is the outcome of the market. We also use Bayesian model to try to kind of analyze the user behaviors and then provide the understanding of how different factors may influence the user behavior. Towards the end of the day, each city may work differently, and each action may work differently. So what we essentially do is we have a number of models for each prediction target, and then we train per city to see what is the effectiveness of each model, and we start assigning weights. So essentially, creating an ensemble model where we assign the weights for each model, each city, and then have the model selections to determine which model or which combination of model may work more effectively for a particular market. I'll probably spend a little bit. So that's try to outline what is how all those models connects. The particular area, let's say the trip models or the incentive models, each of the components here essentially try to predict one target. And ultimately, what we want to understand is number of trips, the gross booking, as I outlined, New York City versus Hyderabad or Bangalore. The same number of trips may generate different economic values. And then we also want to understand potential revenues, the profits, and then fundamentally the core macroeconomics metrics about number of sessions, which is the demand, and then the number of active drivers, which is the supply that we can provide. And those information essentially coming together into a market model to generate, say, given this level of supply, given this level of demand, what is the potential outcome? And so fundamentally, the first value to predict is number of trips. And then from there, there's all pretty much deterministic kind of functions to generate a prediction for the other facts. I want to talk a little bit about optimization. Just having a prediction, essentially given the set of actions and we can understand what is the outcome, is actually not enough for business to make a decision. We also want to recommend to the business, say, what is the potential combination of the actions that is the best, right? Given a limited set of resources, how can we distribute this resource? Back to the example of New York City and Bangalore. Let's say, given a particular action, the optimal spending in New York City is, let's say, $10 million in some actions that will bring us the maximal potentials. And the Bangalore is also $10 million, will bring us the maximal benefit from Bangalore. If I have $20 million budget, awesome, I give $10 million to each. What happens if I only have 12? Do I do 50-50? Do I do 80-40, right? So that comes down to an optimization process. And the way that we're looking into is first, given a set of actions. So given a city, we may have a set of actions. The combination of the actions, let's say a set of AI, essentially is a combination of operation scenario. And this determines how much we are going to spend in each of the action and what is the potential outcome for those actions can bring. And globally, we can construct a number of operation scenarios. Right now, we are still working with cities and operations to try to manually construct those operation scenarios. the future directions is potentially system can generate, automatically generate thousands of operating scenarios. We can walk through for each scenario, we can predict what is the outcome, and then through the process to identify what is the most optimal scenarios for us to consider. And from that perspective, we also can fork into both the regular annual planning forecasting, which is help to determine the budget, versus the continuous forecasting. So continuous forecasting working in the way where if, let's say, from two angles, one is the sudden events, let's say terrorist attack or something happened in the city, some random stuff happens, what we call as a market shock, right? Taking those inputs and try to adjust the results. So that's become a new scenario, on-demand scenario that are created. Second is on the constant basis, when the new operation data coming in, that give us more insights. That is essentially, I mentioned the long-term weather forecasting. The more data we have, the more we can refine our predictions. The continuous process essentially is try to incorporate those latest data sets from the operation and try to refine the prediction or potentially retrain the models. The on-demand cross-level budgeting, this is mostly used for the tactic decisions. So essentially, given, let's say, 10 actions, how do we balance between the actions? We can move budget from one side to the other side, and that will create a different market outcomes. So those decisions will help to decide what is the incentive we give, what is the paid budget we are going to give, and then how much we are going to, let's say, those are the examples of the things that we can influence. At a high level, the process goes through getting all the inputs data from the historical trips. We actually collect, we use 6 years back data for the most, the cities that we have longest operation history, and then acquisition spending. And then all the incentive spending essentially is the behavior that give us understanding of how the user actually responding to those actions. And then for the short-term and the long-term prediction, essentially provide more tactic actions or versus the long-term strategic decisions. So I talk about the scenario generations. Today we generate scenarios using, first we actually provide a data science generated scenario. So this is from the system we compute what is the potential optimal combination of different actions. But then we start working with each city and each region to construct their own scenarios. And those scenarios will help, essentially, you can see it as a source control. People download the data science recommended scenario and then make modifications. Those modifications will submit back into the system and we rerun the prediction. And if people are happy with the outcomes, they will check in the model scenarios that become the latest story. And then, of course, when operation comes in, there's always adjustments that we need to make so that we can continue to kind of refine the data sets. I'll probably skip this, but more looking into this. This is essentially a more detailed outline of how the trip model prediction works. And given multiple stages of the prediction, each stage may influence the next stage. We try to train the model, and each area there's a different kind of model trend for the prediction, and all those things coming together. The system we build essentially is more or less an orchestrator to make sure that all the models can fit together, and then we'll connect the outputs of the model into the next stage inputs. I want to talk a little bit about LTVs. So that's probably the second major things that we try to predict. Given that understanding of the user behavior and also the historical contribution, different cities and different regions, we can actually leverage that information to predict what is the per user value that will bring to Uber. And from model perspective, it's actually nothing fancy. It's a gradient boosting trees, and we run it on PySpark. But we are doing, in fact, two layers of the predictions on the lifetime value. One is on the cohort basis, right? When we create a cohort based on the common behavior pattern, and then we can predict what is the lifetime value for the behavior. We can also try to I wouldn't say we do, but we try to do per user level prediction. But that requires a lot of behavior information, which we may not have. I'll talk a little bit about the platforms. It's a very traditional layered system where most fundamental is the data warehouse. I wouldn't categorize this as big data. The scale of data we have is about in the hundreds of terabytes. So given all the talk we have, that's probably won't consider as big data. Now, just saying as many of the insights or systems or predictions, this is very computational heavy. The amount of data we have is not that big, but the amount of computation that we try to process those data, try to generating the predictions, and essentially, even also with all the scenarios that to create, we potentially have thousands or even tens of thousands scenarios, and each scenario need to compute. With a limited amount of data, but the computation happens many times. So the one thing that I can share is our resource budget is about 95% goes to the CPUs and the memories, and 5% go to storage. Let me see. As this, I think at the center of this, many of the things that we do is quite sensitive, and essentially the revenue predictions, the business outcomes. So we engage a lot on the data access control, the security protections, and very fundamentally, the most critical challenge that we are facing is the data quality. The data quality, there are two different set of things. Number one is the noise in the data. That we pretty much hope that the algorithms and the models can help us to weed those noise in the data. But then there is the intrinsic data quality issues that, given multiple stages of the data collections, the systems that we're running, the reliability of each stage, there's always a concern about what is the quality of data that we feed into these models, and how can we guarantee that we can trust the data. So that becomes one of the most fundamental challenge that we spend a lot of efforts try to understand the quality and try to validate across all the systems to say, yes, we can trust the data. The large part of the group actually is spending on the data collection, data processing, and the data quality efforts. A little bit more detail about the data systems that we build. You can see that the data assurance is the most fundamental layer that we build. From all this on the left-hand side, those are the internal build systems that processing the data and creating all the, let's say this is the revenue, getting the revenue information. Euclid is for the marketing spend. Insurance and the mezzanine is the trip transaction data store. And to many of the external vendor provided systems like Oracle, TM1, Coupa, those give us the operational expense and the cost. Feed into the data assurance layer so that we can try to cross-check between different systems how they validate the data quality, and then some of those streaming into the system so that we can actually organize them into different part of the major data sections. And everything right now stored in the secure Hive. And the meta essentially is a metadata. It's a business metadata management layer that understand how the hierarchy of the cities are organized, and how, if we want to create the scenarios, what is the structure that we can create scenario on. Many of the different things. So just want to say one thing. Essentially, what we're trying to do is try to model a human society and its behavior, its response to corporate actions. By far, this is not a solved problem. I think in the cities where we have longer operation histories, 6 years or even and larger number of transactions, we actually can do a pretty good job on predicting what is the future cohorts can be and what is the people's response to the actions. Large, or I would say majority of the markets, either it's a fast growing, like for example, in the Latin market, it's a fast growing, there's a lot of spending put in there. It's very hard to actually generate accurate predictions. The worst market we can predict is India. Our average prediction accuracy is about 25%. Our annual rate is about 25%, which is almost make it we can do that. So I think the amount of data, I would say, potentially will exponentially grow. As many of the work, the data scientists and the machine learning engineers that they spend is imagine what is potential correlations, what are the different things that we can actually model the user actions. Every time we have one hypothesis, we need to build the model, try to test it, and try to provide the understanding of how effective this can be a prediction. And that potentially will bring in new set of data and new set of computation onto our platform. I think that concludes my session. This is one of the slides being censored. I was hoping to the last minute that I can actually share some data. Apparently not. So, all right.
Thank you very much. Questions? Who's first?
Yeah, I was interested in the modeling in terms of, you said you're doing microeconomic modeling in different communities, and the question is, when you model across communities, how much, what are you finding as being common across communities versus things that may be very unique determinants in a community, and does it have to do with the size and et cetera? And sort of related to that, another question is, you also talked about long-term forecasting, which then gets modified with real data. And have you learned any sort of standard or common lessons in terms of where the long-term forecasting somehow doesn't go right, and what types of local real-time data actually helps that model?
Okay. So first of all, we actually do not do cross-city model. And most of all the models actually is within a market. And the cross-city, what we do is more of the optimization and the building the larger scenarios. So looking at it this way, each city that Uber operates is pretty much a self-contained marketplace. There's very little influence, cross-influence between cities. And what determines the city behavior is about, let's say, the GDPs, the earnings, and the user behavior, like how user is generally engaged, and what is the competition presence, and what is, let's say, the city regulations that actually restricting. And those are very local factors that actually contributing into the prediction. So the models actually is not, we don't do cross-city modeling.
Sorry, I didn't mean cross-city models. I was wondering if you were comparing your models across cities to just as a way of observing.
Yeah. So yes, so there's one of the interesting thing is, given a new city, how do we predict it, right? If there's no historical data, how do we predict it? And that brings up into a study about building the city cohorts, right? How can we identify the two cities are similar? So there are a lot of similarities between cities, and so we building those what we call city segmentations, so that let's say if we need to start into a new city, then we'll study this city based on population, based on income level, and based on all the demographics to actually identify what is kind of comparable cities. And we're using that data to actually predict. Now, first 6 months is always going to be wide, fluctuated. And then we start, once the real operation data comes in, at least we give a first set of targets. And once the real operation data comes in, we can try to refine the model. But the first set of model definitely is borrowed from the comparative city study.
Another question. Stephen?
I was struck by you focused on the events like the national holidays and so on, and it seemed there was less emphasis on sort of local events like, I don't know, South by Southwest in Austin, Texas, or the New York Marathon or whatever. Or even weather would seem to me to be a big, at least as an Uber rider, I know that the Uber drivers tend to, when it gets bad weather, they go offline and they don't want to drive anymore. But there's more demand because people don't want to walk in the rain. It seems to me those would be bigger impacts, and it seemed that they're not really considered.
Weather, we definitely consider it because weather essentially driving the seasonality of the user behavior. So we do. This is an ongoing study to actually incorporate how do we effectively incorporate weather into our models. But the local events, sometimes it's hard to predict. And I think repeated events, we can build a schedule and say how well, but think about this. A lot of time, even a local event has very limited impact. So for example, I give an example, let's say Moscow. Moscow, we divide into 5 sections. A local event probably will influence one section, but it's not likely to influence the entire city. And one of the problems that we're running into is we actually increased one side of the spending on one region, one section in Moscow, and didn't increase the other, and then increase the different spending on different section. That create actually market imbalance. So sometimes responding to the local event may become detrimental to the larger city. So that's kind of a little bit something we still consider. How do we actually incorporate that? And for the local, actually, when I talk about the shortened prediction definitely taking into those considerations. There's 2 things. One is if we can predict the event, then we can preemptively devise actions to counter that event.
What would be an action? Let's take a Giants game.
Mm-hmm.
You know what's going to happen. You don't know exactly what time it's going to end, so it's a little bit tricky.
Yeah.
You know it's on this evening, but you don't know exactly what's going to end. What would be the kind of thing that you would devise to deal with the surge of demand? And yes, it's one area, but it's 60,000 people, so it's
so essentially there's a repeated pattern of the intensity of the demand. And that pattern that we can study, and we can derive that pattern. The potential action is essentially given the pattern we know, then we give incentives to the drivers to actually counter those. And we try to publish that information to the drivers so that they aware of. This is more of the real time. Try to actually bring the drivers into that location. Now the other thing is this is also on the tactical side. We have real-time monitoring all the traffics and demands. One actually common knowledge of what Uber do is surge pricing. When we detect there is a hot spot being generated in certain part of the market, then we increase the surge pricing to bring the supply into that area. And so that's kind of the actions that we can potentially take.
Well, the surge pricing also decreases demand. Because when surge price goes, I know as an Uber user, when I see the surge factor go, then I go to a taxi instead of Uber. Right?
Yes.
So it works both ways.
I do that too.
Yeah.
Yes.
Next question. Yes.
Yeah, just kind of a expansion on what Stephen was just asking about. I'm curious to what degree you involve your market managers in the machine learning process, and to things like Stephen talked about with NFL games. Those are kind of predictable. You know what the schedules are, but there are some markets where there are some dramatic events that perhaps the market manager would know about. For example, I live in South Florida, and every year we have something called Ultra, which brings in 1 million people in 3 days for techno music.
Yep.
Now, if you didn't know the market, you wouldn't know that, but it has a dramatic effect on Uber for those 3 days. So I'm curious if your market managers participate in some way in the training.
Yeah. So 2 things that we do. Number one, of course, we try to leverage all the local operations to help us to understand the user behavior in the way that we call it as, there's a concept we call as cost curve. Cost curve meaning that given different set of activities and what is behavior. So we actually working with cities to validate those prediction results. Second is at the later stage when we come up with the finalized predictions, we always incorporate the local market knowledge. So the city actually can modify both the curves and also the intermediate results. And so we also give them an option, say, once you modify, do you want to recompute? By default, it's going to recompute, but sometimes people don't want to recompute. They just want to insert their knowledge, and especially for those local activities and events, we're in the progress trying to collect the global knowledge about those, but we're always going to be imperfect. And this is always, the local operators always have better knowledge of those, right? So we give them an option to overwrite the system. Once we overwrite, what we do is we collect all the actions that user take. So we do have a very extensive action logs that anyone who modify any data, we're going to track it. And then those actions will feed back into the training so that we can try to incorporate this into the future actions.
Thank you very much, Eddie.
Right.
Really appreciate it, very insightful.